Okay, so you should find lesson 7.1 in Google Classroom and start your Nearpod. If you need to pause the video to get that situated, please do so. So today we're going to start by looking at models that showed what could have caused the lake on Titan to either freeze or evaporate. We have some new features on our models that help show why the phase change occurred. Remember, we learned about the why as far as the energy being transferred in and out, the kinetic energy changing, the freedom of movement. So the energy bar shows how much energy the substance has, and the energy bar is similar to the sim with the color yellow indicating the most energy and gray indicating the lowest energy. The change in energy arrows helps show the direction of energy transfer. So, was energy being transferred in or was energy being transferred out? The energy transfer labels help show if the energy was transferred in or out as well. So, it just labels those arrows. On the next slide, you're going to see a model that one student made showing what could have happened if the methane lake had frozen. Read it over carefully. So take a moment here to read over the model, paying attention to those new features that we have. You can pause the video if you need more time. So the change in energy arrow shows that energy would need to be transferred out of the methane, causing freezing. So in a couple lessons ago, we created this model of or I apologize. We looked at a model. We looked at a model that a student had made of the freezing. So we started with a liquid, where the molecules move around each other. They chose the appearance, and then the solid. The molecules move in place, and what that looks like. So now we're adding to that particular model. And the first thing that was added is this arrow. So this change in energy arrow shows that energy would need to be transferred out of the methane, causing freezing. So liquid has quite a bit of energy, and in order to get to a solid, we have to transfer that energy out. So therefore our solid block is down here where we have lower amount of energy compared to the liquid. So the position of the substance description, as I just said, shows that the methane is at a lower kinetic energy level after the change. So liquids had a significant amount of kinetic energy compared to the solid. On the next slide, you're going to see a model that one student made showing what could have happened if the methane lake had evaporated. Take a moment to read it over carefully. Again, if you need more time, please pause the video. So the change in energy arrow again shows that energy would need to be transferred into the methane, causing evaporation. So this is the model that you created last week or earlier this week, I should say, with me in class or at home. So you start with a liquid. The methane lake was a liquid where the molecules move around each other, and you would choose your appearance. And then after the phase change, it became a gas, which now the molecules can move apart. And this is what it would have looked like. So now in this new model, we have added this arrow with a label that indicates that energy had been transferred out into to get a liquid. Okay, so in order to get to from a liquid to a gas, we have to transfer energy into the substance. So the arrow is showing that increase in energy in order to cause it to evaporate. Notice that the liquid is at a lower kinetic energy as compared to the gas. The gas is at a higher kinetic energy. So the position of those models also make a difference. If you need to, you can refer back to these models during the lesson. To begin the next activity, read the newest message from Dr. Flores on the next slide. To student chemist from Dr. Danella Flores, lead chemist at Universal Space Agency. The subject is request for final scientific argument. Based on your investigations, we are closer to determining what happened to the lake on Titan. We have collected additional evidence, which I am now sending to you. After you analyze the new evidence, please send me a written scientific argument about which claim you think this new evidence best supports. Remember to explain your reasoning. So we've been learning about phase changes, energy, and molecules in part so that we can determine which of the two claims on the next slide best represents or explains what happened to the lake on Titan. Read the claims and examine the images on the next slide. So remember, these are our two claims. At the top here, we have the images that the NASA probe took in 2007 outlining this lake, and again in 2009, where the color of the lake has changed. And we are trying to answer the question, what happened to the lake? We came up with two claims that the lake area in 2009 had either froze or evaporated. If it froze, then that liquid methane turned to solid methane. If it evaporated, that liquid methane left behind, when it evaporated, left behind the solid surface of Titan. Today, you're going to complete a card sort activity to interpret and evaluate evidence about Titan to help you decide which claim you want to support. First, you're going to read and annotate 4 evidence cards. Then you will sort each card under the claim it supports. If both claims are supported, you can place the card in the middle. So evidence card A states Titan from the Titan fact sheet article. However, because it is so far from the sun, even in summer, Titan is very cold. Its average surface temperature is about 179 degrees Celsius or negative 290 degrees Fahrenheit. So evidence card A explains that Titan is very cold even in the summer. If a substance is very cold, as it says, then energy must have been removed from it. The methane molecule's freedom of movement could have changed. If a substance gets cold, molecules can slow down enough so that they only move in place, causing the substance to go from liquid to the solid phase. So this evidence card seems to support the freezing claim, so we can place it in the supports the claim row under the first claim. So you could place evidence card A under supports the claim for the lake froze, based on the reasoning on the previous slide. Next, you will continue to read and annotate each evidence card. Be sure to think about your reasoning as you make notes about each card and where to place it. Use the argumentation sentence starters on the next slide to help you explain your thinking. So as you think about each card, you should be using these sentence starters as well. So I think this evidence supports this claim because. I don't think the evidence supports this claim because. I agree, I disagree, or think to yourself, why do you think that? So you really want to think to yourself, what is going on in each piece of evidence? So go ahead and go to Google Classroom and open number 2 for today, which is interpreting evidence about phase changes. And we're going to read and annotate each card, then sort it under the claim that it supports. So if I go to week 19, number 2, and you want to open up the Google Slides here. Once you get those open, this is what you should see. You can go ahead and pause the video while you get that all set up. So after we finish annotating and sorting, this will be the end of lesson 7.1. But let's first annotate and sort. So, evidence card A, you want to read it and make notes about your thinking. Remember to consider how temperature affects a substance's kinetic energy, how changes in kinetic energy affect the molecule's freedom of movement, and how, in turn, changes in molecules' freedom of movement affects the phase of the substance. So, you want to think about that progression from temperature to kinetic energy to freedom of movement. So I just read evidence card A for you before, and you want to go ahead and make some notes about evidence card A. You will do the same for B and C. Note that C does have a different question for you to think about, and D. Slide 5, once again, gives you those reasoning sentence starters to think about as you begin to sort your evidence. So on the final slide, once you have annotated all 4 cards, you will then take your cards and drag and drop wherever you think that it makes most sense to put the card. When you are finished, you can go ahead and turn in your Google Slides.